Okay, the normal model. Let's talk about chapter 10a. Question straight from the book. What's the probability that z is less than 1? We're thinking about our normal model, our normal bell curve. When we're talking about z numbers, we're talking about a mu or mean of 0 and a standard deviation of 1. And we are thinking, what is the area under where z is 1? So there's my 1 there. It's 1 standard deviation above mean. Z is less than 1, so we're talking about what is that area in there. Okay. We're going to use our calculator function, norm CDF. We're going to put it in the order inside the brackets of our minimum boundary, which is -infinity, to our top boundary, which is 1, then our mean of 0 and a standard deviation of 1. And a calculator is going to spit back 0.841345. Let's put that into context. Let's say that's approximately 84%. That area is 84%. That 84% of the population, the whole population, is under that curve. 84% is under 1 standard deviation above mean. I am going to keep going. Potentially try and cover the whole of chapter 10a in one little video. So the next type of question, I'm going to do question 8, and it says given mu is 9, standard deviation is 3, standardise the value where x is 10. Standardise, okay. So what we're thinking of, to put it into context, is if mu is 9, standard deviation is 3, here's the number 10. The question really says, well, how far away from middle is it? Is it a good result? Is it a bad result? How far away from it is? So we're going to use our rule, z equals x minus mu on standard deviation. X is 10, mu is 9, standard deviation is 3. 10 minus 9 is 1, a third. So I guess if we're talking about marks out of 15, I don't know, the average kid got 9. If the standard deviation is 3 and you got 10, how good is that? Well, what we've just worked out is that you're 1/3 of a standard deviation. That's 1/3 there. You're 1/3 of a standard deviation above normal. Okay. One more style of question. We're going to look at question. Let's go to question 11. It's talking about some sort of light bulbs. I'm going to go straight to the diagram. Now the question says something about the light bulbs. The average light bulb lasts 125 hours, I think. Standard deviation is 3 hours. And the wording is, find the probability that a randomly selected light bulb lasts for longer than 140. So if that's 125, I'm going to say that's 140. What's the chance it lasts for more than 140? I'm looking for that area in there. So, norm CDF. Oops. What's our minimum boundary? What's our maximum boundary? Infinity. What's our mean? And then our standard deviation. Straight in the calculator, we get 0.086341. So that's 8.6% of the population. So what is the probability? Not very good, is it, that you're going to get that light bulb to last that long? That's question A. Question B says less than 100 hours. So potentially, rather than looking for that area there, I'm down here and I'm wanting less than 100 hours over here. So let's get rid of that. So that's A. B would be, what's our minimum boundary? Negative infinity. Top boundary was 100 hours. Mean was 125. Standard deviation 3. Straight on the calculator, and I think it's 0.011521. So that's even less than before. There's not many light bulbs that are duds, is there? Less than 100 hours. Okay, and question C, if I can just squeeze it in there, instead of looking at above or below, we're looking in between. I think it says, what's the chance that your light bulb lasts between 100 and 140 hours? What's my minimum boundary? Maximum boundary? Mean? Standard deviation? And our calculator will pop out. I'm going to squeeze that right down the bottom, 0.902138. So there is 90% of the light bulbs happen in between those two. So that's pretty much where you're likely to get your light bulb. That's all of Chapter 10A that we need to get through. Make sure to do as many as you can.